Alright, page 16, acceleration due to gravity. Dropping a ball from a moving platform. So you really have to understand that when something is moving already, the object on the moving platform is also moving at the same speed. Alright? So the balloon is accelerating upward with acceleration of positive 5 meters per second squared. At the height of 50 meters, right, the ball hits a velocity of positive 7 meters per second, and a ball is dropped from the basket. This positive 5 meters per second squared really has nothing to do with this problem when you really think about it, because it was the balloon that's actually accelerating up, but as it accelerates upward, when the balloon reaches 7 meters per second in positive direction, the ball is dropped. Okay? So from the moving platform, right, this y initial at YA is pretty much 50 meters. Okay? And this ball now will have initial velocity, okay? It would have initial velocity VI of positive 7 meters per second. Because this balloon also has positive 7 meters per second. Okay? So, since it is dropped from a moving platform, okay, right? Therefore, your V initial is equal to positive 7 meters per second. So, describe the motion of the ball as seen by person standing on the ground. So, relative to the person standing in the ground watching that, right? Right? Person on the ground will see the ball go up first. Right? Because, right? Because it would have initial velocity of 5 meters per second going up. And even though, like, the person who's dropping it will see that ball just go straight down immediately. However, person on the ground, because the balloon's moving up and the ball's dropped, the ball will actually follow the balloon initially upwards, but it's going to slow down, and then it's going to start to come back down again relative to the ground observer. Okay? So that's a very important visualization to, see. Okay? However, for relative to the person, like here, observing, right, the ball relative to the moving platform, okay, the person in the moving platform or in the basket, right, which is the moving platform, right, will see the ball immediately go downwards, right? With respect to the basket. Okay? So it's good to know how to visualize that. So the question is, for part B, what maximum height off the ground does the ball reach? So they want, with respect to, right, this person, so here, from here, how high will this ball go? So this ball is going to go actually up, right? It's going to start from here. It's going to go up, and then it's going to come back down again. Okay. So they want to know what is the maximum height, right? So V or Y final Y max is what they want to know. Okay. They want to know how high it will go up with relative to the ground. So from here to here is what they're looking for. Okay. So let's write down what we know and what we're looking for. So we're looking for the Y final position, right? When it reaches the maximum height. And we know we start at initial position of positive 50 meters. We also know VIY is equal to positive 7 meters per second. And we know this balloon is on Earth, therefore my acceleration in the Y direction is negative 10 meters per second squared. What else do we know when it reaches the maximum height? There's one more thing that we could safely assume, and that is what happens when ball reaches the maximum height? It stops. Very good. So my VFY max is equal to 0. And that's very important concept. Right? If you didn't know that, you're not going to have enough information to solve everything. All right? Therefore, well, out of all these variables, it looks like I don't have time here. And when you don't have time, it's good to use equation number 3. And equation number 3 is VFY max squared is equal to VIY squared plus 2AY delta X or delta Y, which is Y final minus the Y initial. That's my delta Y. Right? Therefore, we know final velocity Y max is 0. Square that, you still get 0. Y VIY is 7 meters per second. Square that, plus 2 times negative 10 times Y final, which is what we're looking for, minus Y initial, which is 50. So if you work it out, you're going to get 0 is equal to 49. Here, you're going to have negative 20 times Y. I'm going to distribute this out. So you're going to get negative 20 Y final. Negative 20 times negative 50, you should get positive 1,000. So don't forget to distribute that out. So if I bring this negative 20 Y final to the other side of the equal sign, it becomes positive. And if I add these two, I get 1049. So your Y final is equal to simply 1049 over 20, right? So your y final comes out to 54.45 meters. That's one way of solving it. Now some people may say, what if we find time first and then use that time to figure out what that position is? Yeah, you could do that, you know? So this is an alternative way. You could do find time first, right? So how do we do that? Well, we know my VFY max is equal to 0. We know my VIY is equal to 7 meters per second. My A sub y is equal to negative 10 meters per second squared. I can find for time for y max. Right? I can definitely do that using equation number 1. So if I use equation number 1, which is VFY max is equal to VIY plus A sub y times TY max. So here again, this is 0 is equal to 7 plus negative 10 times TY max. So if I solve for time, bring this to the other side, becomes negative. Divide both sides by negative 10. So my TY max comes out to 0.7 seconds. So once you have this, you can use equation number 2 and say my y final, right, is equal to y initial plus V I y t plus 1/2 a sub y t squared. And you plug this time in here and here to get your position. So your y final is equal to 50 plus 7 times 0.7 plus 1/2 times negative 10 times 0.7 squared. And if you do this correctly, I guarantee you'll probably get it's very similar or almost exact same answer as the previous one. See, there's, yes?
Is it 52 or 54?
52, sorry. Yeah, 52. 52. Sorry. 52. Right, so 52.45. All right. Now they're asking for part C, calculate the total time the ball is in the air. Well, again, I start writing down all the things I know about this. So this thing is basically we start here, and we end up here. And I want to know how much time it takes to go all the way up and then come back down with respect to the ground. All right. So let's write down everything I know. So I know my y initial is 50 meters. My y final happens to be 0 meters, because this is my y final right here, right? And this is my y initial, right? And my VIY is equal to positive 7 meters per second. My A sub y is equal to negative 10 meters per second squared. And I want to know what T total is, right? That's what I want to know. So from here, it looks like I can use equation number 2. These are the same equation that you should have in your calculator, right? On your back of your calculator taped up, okay? Instead of x, we're using y's, basically. So here, your y final is equal to your y initial plus VIY t plus 1/2 a sub y t squared. Now this time and this time are t total, right? So if I plug everything in, 0 is equal to 50 plus 7t plus 1/2 times negative 10 times t squared. It looks like a quadratic equation here. So if I write this in a descending order, I get here negative 5t squared plus 7t plus 50 is equal to 0. So this here is my A, this here is my B, and this here is my C. And if you work it out, right? So you go to program, and then you got negative 5, and 7, and 50. Boom! Your time is equal to, here looks like 3.94 seconds or negative 2.54 seconds. Obviously, you cannot have negative time. That's extraneous solution, so the positive time will be the correct answer. Is that good? All right. All right then. So, any questions? We good? Should we move on? All right, let's take a look at page 7. I really like this problem a lot. All right? I really like this problem a lot. So you really should know how to do such problems with moving platforms as well. Alright, I assigned this for homework. So let's take a look at what it's going to be like here. So number 1, a ball is dropped from rest from a tower and strikes the ground 125 meters below. So let's give it a little here. All right, let's draw it out. No, we're not playing hangman, right? So here, my y initial y position is 125 meters, and the ball is going to be dropped. So my v initial happens to be 0 meters per second. Okay, and my y final is equal to 0 meters. We all know acceleration in y direction is negative 10 meters per second squared, and when the ball is right here at y final, what is my t total is what they're looking for, right? So if you look at all these givens, it looks like my equation number 2 should work very nicely for us, right? So equation number 2 is simply y final is equal to y initial plus v I y t plus 1/2 a sub y t squared. Therefore, if you plug in 0 for your y final, plug in 125 for your y initial, plus VIY happens to be 0, right? So this VIY is 0 because it's dropped. So this whole term just goes to 0, plus 1/2 times negative 10 times t squared. So if you clean this up, you're going to get 0 is equal to 125 minus 5t squared. Bring this to the other side, you get 5t squared is equal to 125. So t squared is equal to, right, 125 over 5, which is 25. So t is equal to plus or minus square root of 25, which is plus or minus 5 seconds. But which one do we pick? Just the positive one. Good. So t total is equal to just 5 seconds. All right. I think half the battle is like reading the problem like very carefully, and then recognizing what's given to you. And like as soon as you recognize, oh, this is this, and this is this, and you could recognize it by looking at the units. Right, this one right here, you know, this is like y initial. You know, this position drop from rest, which means initial velocity 0, and you could always count on acceleration due to gravity in the y direction to be negative 10 meters per second squared. So that's automatic. And then other things like, you know, maximum height, velocity is 0. So those things should be recognized, and you could only do that if you practice enough. All right, let's take a look at number 2. A ball is shot straight up from the surface of the earth with the initial speed of 60 meters per second. So here's my earth, here's my surface of the earth, and the ball is shot straight up with the initial velocity of 60 meters per second. Just by knowing that, you should be able to figure out how long it's going to take to go up to the maximum height. Because every second it should slow down by how much? 10 meters per second every second, because acceleration due to gravity is pulling it downwards 10 meters per second every second. So if you start at 60, 1 second later you should be moving at 50 meters per second. 2 seconds later, 40 meters per second. 3 seconds later, 30 meters per second, and so on. So how long will it take to reach the maximum height? 6 seconds. So you should be able to think that out, straight out. All right? And this is your y initial, and your y initial is at the ground level, so that's my 0 meters. Then it's going to reach a maximum height somewhere. I don't know where it's going to, you know. And that is your y max, right? Y max. And that's what we're looking for. Okay. Well, before that, they want us to know what is your y position of the ball after 1 second. So let's do that. So for part A, right, you know your time, t is equal to 1.00 seconds. They want to know what your y final is when t is equal to 1 second, right? We know the initial velocity in y, which is positive 60 meters per second. Right? We also know one more thing. This is on Earth, so we could always safely assume my a sub y is equal to negative 10 meters per second, or 10 meters per second squared. So my acceleration in y is equal to negative 10 meters per second squared. So with this, you could probably use equation number 2 again, and saying y final is equal to y initial plus VIYT plus 1/2 a sub y t squared. Now this t is 1 second. So let's take a look at what my y final is. Y initial is 0 plus 60 times 1 plus 1/2 times negative 10 times 1 squared. So my y final is equal to 60 minus 5, which is 55 meters. Is that okay? Okay. What about part B? Part B asks, what is the velocity of the ball after 1 second? We already answered that question, but let's work it out anyway. So when t is equal to 1 second, I want to know what my VFY is. Okay. I already know my initial velocity in y, which is 60 meters per second, and I know a sub y, which is negative 10 meters per second squared. Looks like I can use my equation number 1, which is VFY is equal to VIY plus a sub y times time. So my VFY is equal to 60 plus negative 10 times 1. Therefore, my VFY is equal to 50 meters per second. So that was easy. I mean, we already knew that it was going to go at 50 after 1 second. And that was B. And this is second B. Well, let's make that C. And let's make this D. Okay? So for C, they're asking, what maximum height will the ball reach? So they want to know what Y max is, right? And we know my Y initial is equal to 0. So this Y max is our new Y final, right? And we also know initial velocity in y is 60 meters per second. We know VFY is equal to VFY max is 0, right? 0. Because at maximum height, my VFY max is 0 meters per second. And we also know my a sub y is equal to negative 10 meters per second squared. So we know all these from our problem. So we can use, looks like I have no time here, so I can use equation number 3, which is VFY max squared is equal to VIY squared plus 2 times AY times Y final minus Y initial. That's delta Y. Therefore, we know this is 0, square that, still get 0. You know this is 60, square that, you get a big number, plus 2 times negative 10 times Y final, which is what we're looking for, minus 0. So 0 is equal to 3,600 minus 20 times Y final is negative 20 Y final. Then negative 20 times negative 0 is plus 0. So I get 20 Y final is equal to 3,600. So my Y final is equal to 180 meters. That's my Y final. And then for part D, they want to know how much time elapses between leaving the ground and returning to the surface. Well, if we could find out how much time it takes to go to the maximum height and double it, we'll know the total time, right? So T total is equal to 2 times Ty max, right? So if we could figure out Ty max, then we can figure out how much time it's going to take to go up and down. Alright? So we know my VFY max is 0. We already know that. We also know VIY is equal to 60 meters per second. And I know A sub y is equal to what's my A sub y? Negative 10 meters per second squared. So it looks like I can use equation number 1, right? I can use equation number 1, which is VFY max is equal to VIY plus A sub y times Ty max. So this is 0. this here is 60 plus -10 times ty max. So it looks like my ty max happens to be 60 over 10, right? Which is 6 seconds. That means my t total is 2 times 6 seconds, which is 12 seconds. It's the t total. Or another alternative way for part D is if you were to think about, this is the Earth, right? We start here, right? We start here going up at, right? VI is equal to 60 meters per second. And it's going to go all the way up, and it's going to come back down to the same height, right? Same height. So this is your initial, and this is your final, right? So your y initial is 0, and your y final is also equal to 0, right? So if you use this idea, you could use the second equation and say y final is equal to y initial plus VIY t total plus 1/2 AYT total squared. Because now we're looking at initial and this is final, so we're looking at the total time. Okay? So here, 0 is equal to 0, so both are 0, plus VIY, which is 60 times t total, right? Plus 1/2 times -10 times t total squared. So if you work this out, my 0 is equal to, I'm going to factor out one of the t totals, and 60 minus 5 t total. So t total is either equal to 0 or 60 divided by 5, right, which is 12 seconds. Obviously that makes perfect sense, because at 0 seconds my position was at 0, and 12 seconds later my position is also 0 again. So since they want to know total time that stays up in the air, we can say it's 12 seconds. Okay? Yeah, that doesn't look right. I'm sorry. Physics sometimes can draw some really weird, funny things. Okay? Please don't elaborate on that. I'm done for today. So if you can work on page 18 and 19 and 20 for your homework, right? And check your understanding, please. Check your understanding. And I think we'll be ready. We'll go over these 3 pages tomorrow. And then on Wednesday, I'll give you a little, like 15 minutes to like sort of, you know, like review if you want any last minute questions. Okay? And then if you don't, we'll start the quest. Okay?
Are you going to test review?
I'm sorry?
Are you going to get a test review? A test review?
This is it. Yeah. I'm not going to keep holding your hands and spoon feed you for the rest of the year. I know I did that at the beginning of the year, right? Just to ease your anxiety. But now, this is honors. So come on, right? Now I'm not going to hold hands anymore and spoon feed you for the rest of the year. So let's try these.